All right, so we got another section here to do, talking about structures. Now, I normally thought of these as a C++ thing, but they're in C too. You can define a structure and have just a bunch of data stored here. So you've got a student structure, and it's got a name and an age and a GPA as a floating point and another integer. So you just have a lot of data. And then you can refer to it by the name, define the structure, and then use student 1 age, student 1 GPA, and so on. So these are ways to access the field values, to assign them. This will put Ruth into student 1 name. Notice, by the way, you cannot just set a string value like student 1 name equal to Ruth, the way you do with numbers. This is a reminder of you, these things called strings in C are not really at all the same as the other variables like integers and such. And when you handle them, you're really just handling byte arrays, and it's easy to make mistakes with them, which we'll see leads to a lot of security problems. So here's a structure on the stack that has the data stored in it this way, or you could have that same structure in the heap, malloc it, and then you'd have an address probably in the stack to be pointing to it. All right, and then you got input output. So this is important, and this is true of all Unix. And remember, the whole reason C exists is to write the operating system Unix. Standard in is the standard input, standard out is the standard output, and standard error is where error messages go. And they're typically 0, 1, and 2. Standard input reads from the keyboard. Standard output is the monitor, the screen you can see text appearing on. And standard error typically also goes to the monitor, but it is a different channel. You could redirect it to a log or something. And that's why if you start doing output redirection in bash command line, you often find that it's a little difficult to redirect standard error to get rid of irritating error messages from commands. But anyway, that's the point. Scanf reads from standard in, and printf writes to standard out. And you can use fscanf and fprintf to print to other things other than the standard in and standard out. Anyway, so input and output redirection from a shell, like I say, if I have a program, I can take its input from infile instead of from standard in. So I could make a file that includes whatever data I was going to type in and feed it in. I can take the output and put it in standard out. Now this is how you redirect standard out and standard error to a file. And this is the way I've always seen it. Here's how you do it specifically. You can say 1 goes to out file and 2 goes here. Remember, 1 is standard out, 2 is standard error, and 0 is standard in. They don't mention it here, but it is. And so this is a program which, instead of taking input from the keyboard and putting output on the monitor, is now going to take input from this file, and it's going to put the output in that file and the errors in that file. So that's output and input redirection from the bash command line, really from any shell. All right. Here's another way. This, by the way, is the way I always learned to do it. 2 arrow ampersand 1. That's another way to do it. I think what this does is it redirects output 2 into output 1. All right, but anyway, that's another, and this redirects output 1 to go there. Another way to do it. Anyway, there are various ways to do it. All right, so printf is here. You do a printf, x is %d and y is %d. That's going to print 5 and 10, x is 5 and y is 10, pi is 3.14. Here I'm going to print pi as a %g. That's going to be a floating point. Then I have a tab and a string and a tab and a decimal. So there's a tab going here and a tab going there. All right. So here's your formatting placeholders. F and G are for float and double. Decimal is D. And you got unsigned decimal and a single character here, a string value, and a pointer, P for pointer, for an address value. And you can have long versions of quite a few of those if you define long variables that are double size. And %x is hexadecimal. I use that a lot to print out addresses and such. %d for normal numbers. You can also print in octal, base 8. I don't think anybody hardly uses octal anymore. Pretty much just use decimal or hexadecimal. All right, there is no binary option, not in C. All right, so scanf reads from standard in, and this can get you in trouble. if you scanf %d%g, the only purpose of these placeholders is to tell it how to interpret the data. It will expect to see white space between them, and the white space could be spaces or tabs or carriage returns or anything. So it's going to read an integer and then a floating point value from what comes in. Get character and put character will read or write a single character. That's another way to go. So if you want to do input or output to a file, read from a file or output to a file, you have to declare a file star variable. That'll give you a pointer to the file, and then you have to open the file with fopen. So you open the file with the name of the file and then the mode, read, write, and it probably isn't append. I don't think I've used it. Yeah, read and write I know exists. There might be an append too. So you open input to read and output for write, and then you'll be able to read from this file and print to that file. So you can also use getC to get a character from the file, and you can use putC to put a character in the out file. You read and write character by character if you want to. And then when you're done, you can close the file. All right. So this is going to read the next character, fgetC, from the file. This is going to write the next character. This is going to push a character onto the file stream. By the way, this is important to know. If you write things character by character, they might not appear in the file right away. You're going to go into some kind of stream which will only move when the file is closed or when the stream reaches a certain size. So when I'm writing programs that put things on the screen and I want to read them, this is often irritating, and there is an flush command to force it to finish sending the data that's waiting if you want to see it right away instead of it piling up to some default size before it bothers to write a block of data. So this will read n-1 characters in. So this will read fgets will read characters up to this number from that file. And if it hits a new line, then it will stop. And this is going to write the string into the file stream. All right, and then you can do formatted with fprintf. That's what I normally use, fprintf into a file. Then you can have a format, so you'll have like fprintf into the standard error returned value %d, carriage return, and then a number. This way you put a formatted line of data out, which is typically what you want to do. And you can read data the same way. Scanf, fscanf will read from a file, scanf will read from standard in. So here's format string for fscanf, the same old thing, integer, float, character, and I've never used these things. Read just digits, read up to the first character, not in brackets. That's interesting. I've never used those screwy things. They might be useful for reading strange formatted things coming in. All right, and so there's a few advanced features. Command line arguments are very useful. You have int argc and char star argv bracket. This will give you the ability to have command line arguments for your program. So instead of just running a.out, you'd run a.out and then have parameters here like 10, 11, and 200. So in this case, argc will count the total number of items on this line, including the name of the program. So there's always at least one. And in this case, there's going to be 4. The first number counts how many there are. The next one is an array, including all the elements. So argv 0 is here, 1, 2, and 3. That's the game, followed by a null. So you get a total of argc plus 1 elements if you count the null. So if I enter a.out, 10, 11, 200, the first argument is a.out, then 10, 11, 200, and then a null. And they're all string types, by the way. Even though these look like numbers, they're actually interpreted as strings. You're going to have to pass them in a2i or a2f functions if you want to convert them into numbers. All right, and so here's a2i and a2f like we talked about to convert those string values into the numbers. And then you can do pointer arithmetic. You can define a character array here, a number array here, and a 2-dimensional matrix here. And you can declare pointer variables that will refer to them, and then you can calculate the pointers. This will make the pointer point to the first character in the letters array, and this will point to the address of elements 0, the numbers array. And you could add to the pointers if you wanted to manually control the address instead of just having this square bracket and referring to it by an index. So here, I'll do it that way. C pointer points to a character array. I'm going to set it equal to a plus I, like we did before. So it's going to be A, B, C, D. This is going to keep. This is going to point to the current value of C pointer, which we initialized here to point to the start of the letters, and then it's going to add 1 to it. So we'll go 1 byte on. Now here, I'm going to set an integer in the I pointer. Now I is, I pointer is numbers, and those are integers. So they're 4 bytes each. So I'm looking to see how this is going to work. Oh, yes. This is the nastiness. Plus plus means if it's a pointer, it knows how big the data is. So adding 1 to the pointer will jump to the next value, even though this is going to move the address by 4 and this is going to move the address by 1. So that's kind of confusing, but that's how it works. All right. And so here we are using indexing to access this. Yeah, this is indexing. This is the way you normally do it. You use the square bracket to say I want letters sub 0, letters sub 1, letters sub 2. You could do it with pointer arrays. Instead of letters sub I, you do star C pointer and C pointer plus plus, which will count through it. It's a way to do it with pointers. This is much more difficult and confusing. You wouldn't normally do that, but you could. This is the more clean way to do it, more like the way a modern high-level language would do it. And so you're going to get the same answer in both cases. All right, let's try another Kahoot. Whoa. All right. All right. Okay, so which command line will send the standard input to a file? Or read from a file instead of standard input? There's a better way to say it. This is input redirection. Yep, this one. This will it's the less than sign. It'll read from the file instead of standard in and feed that data in. All right, where does printf write to? It writes to the standard output, all right, which is the monitor, you can see. All right, in this declaration, what variable contains the name of the executable file? Yeah, it's argv0. It's the first item in the list of arguments is the name of the file that's running. All right. right. All right.